Hello everybody, welcome back. Today we are doing notes number 50, and this is our fourth installment in our Solving Trig Equations series. Now you probably noticed something unusual. Usually I have these beautiful slides, they're all color-coded and everything's typed up ahead of time. Well, I have a lesson to share with you, a lesson inside the lesson. I'm a bit of a perfectionist, and I know that some of you are too. And sometimes we expect a lot of ourselves. Like I expect that I'm going to spend an extra half an hour typing everything and making it all pretty and choosing colors and making it look so professional. And it dawned on me that sometimes we just have to give ourselves a break and let that go, and it'll be okay. So for today, I'm just going to write my entire lesson without typing anything. And I hope that some of you will give yourselves a break too at times. I know that I'm stuck on the computer all day and it can be a little hard on my eyes, and so I'm just going to do more handwriting today and less computer work. And you know, as long as I'm kind of on my soapbox and trying to give wisdom and advice, I thought I would share with you that since it's been kind of rainy this week, it's been feeling a little more chilly. Maybe you've been feeling chilly too. Last week we had a lot of sun and it was really warm. So I was going to ask you, do you know how to keep warm in a cold room? Well, here's my advice. Move to the corner. It's always 90 degrees. Okay, let's get on with today's lesson. So here's our first example. We have cosine of 2x equals the square root of 3 over 2, and we're going to solve for exact solutions over the interval from 0 to 2 pi. So notice that we have 2x in here instead of just x. We call that a double angle. But if you just think about order of operations, the first thing you need to do to get x by itself is you need to undo the outside function, which in this case is cosine. So we're going to take the inverse cosine of both sides, and that leaves us with 2x equals inverse cosine of square root 3 over 2. Now we know how to find inverse cosine of square root 3 over 2. Let's see, it's positive, so we would be in quadrant 1 or quadrant 4. And the square root 3 would be on the adjacent, and the 2 would be on the hypotenuse. So we are looking at a 30-degree angle there. So first of all, I like to think in degrees, and then we'll switch over to radians. So 2x is going to be equal to 30 degrees or 330 degrees. Okay, so if we switch that over to radians, we have that 2x is equal to pi over 6 radians or 11 pi over 6 radians. Now, what are we going to do to get x? We just found the value of 2x. Well, the logical thing from all of our algebraic background would be to divide both sides by 2, and that's exactly right. So x is going to be what we get when we divide each of these answers by 2. Divide pi over 6 by 2 and you have pi over 12, and divide 11 pi over 6 by 2 and you have 11 pi over 12. But wait, there's more. Remember that we were looking for all solutions over the interval from 0 to 2 pi. And by dividing things by 2, we just took our answers that fell between 0 and 2 pi, and we got answers that fell between 0 and 1 pi. So actually what we could do, if we go back a couple steps, is we could do what I call going around the circle again. So our first two answers were from going to quadrant 1 and quadrant 4 one time. What if we went around the circle again? We would get to 390 degrees. That's coterminal with 30. And we would get to 690 degrees. That's coterminal with 330. And the corresponding radian measures for those would be, let's see, 13 pi over 6 and 23 pi over 6. And then when we divide those by 2, we have 13 pi over 12 and 23 pi over 12. Do you see how that is still within the range of 0 to 2 pi? If you think of 23 over 12, it's slightly less than 24 over 12, so it's definitely less than 2. Okay, so here is sort of a summary of what to do. If you have a 2x, go around the circle twice. Get twice as many answers. Get the answers that you would get between 0 and 4 pi, so that when you divide by 2, you'll have all the answers that fall between 0 and 2 pi. Okay. Let's move on to problem number 2. For this one also, we're going to be finding all of our answers between 0 and 2 pi, and we have sine of 3x equals negative 1. So let's think about what we just did on the last problem. We had a 2x, we ended up going twice as far, 2 times around the circle. We have a 3x, we're going to end up going 3 times around the circle. So that's coming later in the problem. For now, what we want to do is take the inverse sine of both sides. 3x equals inverse sine of negative 1. And now let's figure out that angle. So the angle whose sine is negative 1 would be 270 degrees, and that would be 3 pi over 2 radians. So 3x equals 3 pi over 2. That's the one answer you get when you go around the circle one time. Now we're going to go around the circle again. So we're going to add 2 pi to this answer. One full circle is 2 pi radians. So if you add 2 pi, you're adding 4 halves pi. So that would give us 7 pi over 2. And now we're going to go around the circle a third time. So we add another 2 pi. So we end up with 11 pi over 2. And then finally, we're going to divide all of these by 3 to get x by itself. So we have pi over 2, 7 pi over 6, and 11 pi over 6. Okay, let's take a look at number 3. Okay, this problem maybe looks more complicated. It's not really more difficult, it's just that it has a few more steps. So we're going to start by subtracting 1 from both sides. And then dividing both sides by square root 2. Remember, for the sake of finding the exact value, you don't have to rationalize that fraction. Now we're going to find the inverse sine of negative 1 over square root 2. Okay, it's negative, so we're in quadrant 3 or quadrant 4 for sine to be negative. And we want the 1 on the opposite and the square root 2 on the hypotenuse. So we know this is going to be a 45-degree angle. So that means we have 225 and we have 315. Now, because we have the 2 here, we're going to need to go around the circle again and get 2 more answers. But we don't have to do that now. We can do it now if we want to, or we can wait and change things into radians and then do it. So that's what I'm going to do. So I'm going to take these 2 answers I already have, change them into radians. So we have 5 pi over 4 and 7 pi over 4. Now I'm going to go around the circle again. So I need to add 2 pi to each of these answers, and 2 pi is equivalent to 8 pi over 4, and so that gives us 13 pi over 4 and 15 pi over 4. All right, let's take a look at number 4. For number 4, we're going to do it twice, so we have part A and part B. In part A, we're going to do what we have been doing and use the interval from 0 to 2 pi. And for part B, we're going to find all solutions, the infinitely many solutions, kind of like what we did in the last lesson. Okay, and the thing that you'll notice that's different here is we have pi over 2. So instead of 2 pi, 3 pi, 4 pi, something like that, with pi over 2, we have 1/2 pi. And even if it's not written in, you can think of it as having parentheses around the pi over 2. So the first thing we want to do here is take the inverse cosine of both sides. pi over 2 equals inverse cosine of 1/2. Figure out where you are. So we've got, for cosine to be positive, we have quadrant 1 and quadrant 4. We have a 1 on the adjacent and a 2 on the hypotenuse, so square root 3 is the opposite. So we have a 60-degree angle. So our answers are, for the first time around the circle, we have pi over 3. That would be our 60 degrees. And we have 5 pi over 3. Is that right? Yeah. 5 pi over 3, that is our 300 degrees. Now, when we had 2 theta or 3 theta or something, we went around the circle twice or 3 times. But look what's happening here. Because we have theta over 2, what we're going to do is end up doubling both sides. So we actually could only go around the circle 1/2 of the time because we're about to double our answers. And that means that, well, let me just show you what happens when I double my answers. Multiply both sides by 2, we get 2 pi over 3. That's totally fine. That falls in our interval. And we get 10 pi over 3. But that's not between 0 and 2 pi. So we can't keep that one. So if you're going to double everything, you're only going to go around your circle half a time instead of a full time or multiple times. So that's the answer if we're doing part A. Now let's go back and do part B. So we've already done most of the work. We got to the point where we had theta over 2 equals pi over 3. And now we don't eliminate anything. Now we want all solutions. And so we would say that one was pi over 3 plus 2 pi n. Remember, we add everything that's coterminal with pi over 3. And our other solution would be 5 pi over 3 plus 2 pi n. But those are equal to theta over 2, right? We need to know what theta is. So we're going to double these answers. So theta equals 2 pi over 3 plus 4 pi n. We're going to double the 2 pi n. And we have theta equals 10 pi over 3 plus 4 pi n. And that's part B. All right, for your practicing pleasure, I have created trig equation worksheet number 4 for you. And I don't know if you'll think this is good news or not, because I bet, like me, you've really been enjoying this trip through all the different kinds of trig equations you could solve, and you probably don't want it to end, but I'm here to report that this was the last lesson in the trig equation series. We've covered all the different types that we needed to, and I think next time what we'll do is a practice day where you don't have to learn anything new, but you can practice the different kinds of equations that we've been doing over the course of the last couple of weeks. Thank you, everybody. You're doing wonderfully. Thank you for the pictures that you send me and the notes that you send me and all the ways that you're bringing me smiles every day. Here's one for you.